Hello, I'm Jonathan Aldrich, and today we're going to talk about programming language syntax. Let's start with specifying syntax, which we'll do via regular expressions. Unlike natural languages, computer languages have to be specified precisely, both so that programmers and computers can understand what a program should do. So there are two aspects to specifying a programming language. The syntax describes the form of a program. For example, a number is a sequence of digits where the digits are 0 through 9, whereas the semantics describes the program's meaning. So the meaning of a number is given by associating some kind of base 10 place value interpretation with each string of digits. Here, we'll focus on syntax, whereas semantics will be the topic of Chapter 4 in a future lecture. So let's start with a simple specification of syntax. We'll start by specifying the idea of a digit. We'll describe a digit on the left here as one of the following: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The familiar digits that we all know from Arabic numerals. So the notation here, we're using the arrow to say that a digit is one of the following possibilities, and the or symbol, the bar, specifies what the different possibilities are. So once we have the concept of a digit, we can build up natural numbers from that. So it might be useful to have a non-zero digit, because if we're going to have a number with multiple digits, we don't want it to start with 0. So a non-zero digit is just 1 through 9. And then a natural number starts with a non-zero digit and then ends with some sequence of digits. Here we use digit star to mean 0 or more digits. So we could have just a single digit, 1 through 9. We're going to skip 0, considering the natural numbers start with 1, and then any number of digits, which could be in 0, coming after that first digits. So simple concepts like these can be expressed with what's called regular expressions. So let's look at regular expression. In fact, what we've looked at so far are regular expressions. It's one of the following. It can be a character. It can be an empty string, which is denoted by epsilon. It can be two regular expressions concatenated together, which means you sequence one first and then the other one. You can have two regular expressions separated by or the vertical bar, right? So either this one or that one. So that's why we have 1 or 2 or 3 or 4. You can see the concatenation in this example too. So non-zero digit followed by digit, that's a concatenation. And finally, this Kleene star, or the star, is a concatenation of 0 or more of something, right? So that's why we have 0 or more digits at the end. Where does the name Kleene star come from? Well, that's one more of our programming language people. In this case, it's Stephen Kleene. He was a mathematician at the University of Wisconsin and was responsible for a lot of the early development of the theory of computation, including work on formal languages. And so the Kleene star, which we use in regular expressions, is named after him. So regular expressions, we can specify more interesting regular expressions. Here are numerical constants that might be accepted by a simple handheld calculator. Okay, so here we're going to include decimal numbers and scientific notation with exponents and so on. So how can we describe this? Well, a number is either an integer or a real number. An integer is simply a digit followed by 0 or more additional digits. I want to include 0, and so I'm not going to specify the fact that 0 can't come first. We could use a slightly more complicated regular expression if we wanted to express that. For a real number, it's going to be an integer, but it's going to, it could be an integer with an exponent added to it, or it can be a decimal, something with a dot in it, right? And then either they can have an optional exponent at the end, right? And so we'll use parentheses here to group something and say that after the decimal comes either an exponent or the empty string, which just is another way of saying the exponent is optional. Sometimes notationally we will use a question mark to say exponent question mark, and that means the same thing as exponent or e. We don't need question mark as a fundamental construct because we can build it out of the or, but it is sometimes useful. So now let's break down what a decimal is. Okay, so a decimal is any number that has a dot in it, but we can only have one dot. So what we're going to do is have 0 more sequences of digits, and then we'll have a dot, and then another sequence of 0 more digits, right? But we don't want to have just a dot and no digit either before or after it. So I'm going to refine that a little bit and have in parentheses here, either we have dot digit or digit dot, right, in the middle. And so that means we have at least one digit either right before or right after the dot. And then we can have 0 or more additional digits, again, either before or after the dot. So that gives us decimals. What does an exponent look like? Well, we're going to use the scientific notation, so e and then the exponent number. So we'll allow, in this case, either a lowercase or a capital E in our notation. We'll allow the exponent to be positive or negative, or you can leave it out. That's what epsilon is. And so if we leave it out, it's just assumed to be positive. And then at the end of e to the plus, whatever, the whatever is another integer. Okay, so that's a very simple specification of numbers that can now they're a little more interesting numbers, right? Numbers we might use in a calculator with decimals and exponents and so on. Okay, so let's get some practice. Go ahead and define a regular expression for C-style comments. You can use abbreviations like non-star or new line. You can also use something called the Kleene plus. That just means one or more. So it's very similar to Kleene star, but it might be convenient. All right, so in this lesson, we specified simple forms of syntax using regular expressions. The next lesson, we'll look at more interesting specifications of languages using context-free grammars. A reminder, if you like this video, if you enjoy this video, like and subscribe, and check out our textbook for more details. See you next time.